I've opened up Maya on my machine. I'm running version 4.0 on Windows NT. First, I'm going to copy the data directory we've supplied on the DVD to my local drive. The structure of this directory functions as a project directory, so once it's copied to my home Maya projects, I set this directory to be the current project by selecting the menu item File, Project, Set, and click on the directory collective_particles1. The first particle effect we're going to discuss is a simple smoke effect created with sprites, which was developed to emulate smoke from skidding car tires. The technique used here is important because the properties built into these particles are common to quite a few other techniques. These properties encompass what happens during a particle's lifespan, or from the time it's born to the time it dies. Questions we must ask ourselves include, does the particle become more or less dense as it gets older? Is it affected by other particles or objects? Is it affected by gravity or other forces? I find myself asking the same questions for almost every particle simulation I work on. My goal is to build a precise level of control into my simulations so that I can essentially use the same techniques to achieve drastically different results. I've opened the file Chapter 2 Tire Smoke Base in the Scenes directory of my project directory. The animation's 59 frames long. If I play through the entire frame range, you'll see there's an IndyCar animated skidding towards camera. The idea here is to emit smoke from underneath each tire. I've created 4 small poly planes under each tire which will act as surface emitters. Each plane follows its respective tire through a point and orient constraint. If I add a surface emitter to all 4 of these planes using the default settings, you can see how the particles are laid down in quite a regular fashion. A really nice feature is Maya's ability to emit into a single particle object from multiple emitters. This means we only have to modify a single particle object no matter where the simulation occurs in the scene. You can assign or unassign a particle's emission from any emitter using the Dynamic Relationships window by selecting the particle and clicking on the Emitters button. Just highlight the emitters you want to spit out your particles. Let's work on the emission of the particles first. I've animated the rate attribute of all 4 emitters so that the amount of particles ramps in when the car starts to slide. I've also offset that rate slightly for each wheel to add a bit of variation in each tire's smoke amount. It's important to note that small variations in your simulation will add to your shot's level of realism. For example, the front left tire is on the leading wheel in the car's skid. Therefore, the car's physics would put the most force on that one tire. I've tweaked that tire's corresponding emitter to spit out more than twice as many particles as the other 3 tires. If I wanted, I could write an expression that would determine a multiplier for each emitter's rate based on the roll, pitch, and yaw of the car's body. The particles are completely static as they're emitted. I want the particles to adopt some of the car's movement, so I'm going to change the particle object's inherit factor to 0.25. Now the particles follow the car a bit, but don't spread out at all. To achieve this, I'm going to add some speed to the emitters. I select all 4 emitters, and in the channel box, I change their speed to 5. This will have no effect until I turn up the emitter's tangent speed, which will accelerate emission based on each point's tangent or along the surface. I'll set my tangent speed to 1. Back in Maya version 3, they added a new feature that allows you to randomize the speed of emission. This produces some really nice results, so I'm going to set the emitter's speed random attribute to 0.4. This will further enhance the unpredictable nature of the smoke's creation. Now that we've got the particles being emitted in a decent fashion, we need to control their lifespan. Right now they have an unlimited lifespan. I'm going to set the smoke's per particle lifespan attribute using a creation expression. You have to tell Maya to use this attribute under the Lifespan Attributes section of the Particles Attribute Editor. The other 3 lifespan modes let you do things like specify a single lifespan for all particles, define a random range, or have your particles live forever, as is necessary in soft body simulations, which we'll cover later. Now I want to declare a random value for each particle's lifespan. I'm going to do this with a creation expression, which is essentially an expression that gets evaluated once for every particle on the frame it's born. The other type of expression we'll be using is a runtime expression, which gets evaluated for every particle for every frame the particle's alive except for its birth frame. Throughout this DVD, I'll be using particle expressions extensively. They're an extremely powerful way of adding precise control to the behavior of your simulations. I tend to use some moderately complicated mathematical functions, but as we get further along, you'll see how much control I have over the scene. Note how Maya puts all your particle creation and runtime calculations in a single expression. Don't be confused by this. All these per particle attributes connect to the same creation or runtime expression. You can view all your expressions in the expression editor. To learn more about the expression editor, see the Maya Dynamics documentation. I prefer to use an alternate editor to work with expressions, in this case Vim or VIM, which gives me MEL syntax highlighting, automatic indentation, and many other benefits you will soon see. To find out how I've set this alternate editor, see Chapter 10. I need to control the lifespan of each particle using the rand function. I'm going to open the creation expression for the particles and add this line. This rand function returns a random number between the first and second argument. It gets called for every single particle, so each particle gets assigned a different value. Remember, any lifespan or age values you enter in particle expressions are in seconds. This makes it easy if you need to convert a scene from film to NTSC, for example. I'm also going to add a randomization to the particle's velocity to give it some added variation. This is similar to the lifespan line, but by using the times equals function, the current velocity is preserved and multiplied by the random number. Multiplying a vector by a single float maintains its trajectory, yet multiplies its length by the specified value. Velocity is a built-in attribute for all particle objects. I want the smoke to rise slowly into the air after the particles are born. I could do this with a field, but in this case I want more control over the way each particle rises. If I were to use a field such as wind blowing up the y-axis, I'd have to play with the particle's mass in order for some particles to float faster than others. This could potentially change the way other fields affect my particles. I'm going to add a per-particle float called buoyancy pp to my smoke and declare its value in my creation expression. The reason you see the rand function multiplied by 0.55 is simply a more efficient way of editing your expressions. At first, I tried the values 0.3 to 0.5 and found that I liked the distribution or amount of variation between the slowest and fastest particles. However, the overall buoyancy of the particles is simply too much. I multiply a range that I like by an amount I want to reduce the overall effect. This buoyancy pp attribute is just a multiplier for how much to raise each particle in the y-axis. In order to use this attribute, I'm going to apply it to the particle's runtime expression. In the runtime expression, I want to affect the particle's position attribute, which is another built-in vector array. Because it's a vector, I have to be careful about the syntax I use to apply the buoyancy. This means that for every frame, the particle's buoyancy pp value will be added to its y position. In the final scene files included with this DVD, you'll see all the expressions commented to help you better understand what each line is doing. Comments may seem redundant at this point, but when you're looking at someone else's 150-line runtime expression, you'll be thanking them for adding comments. Get in the habit of commenting even the shortest expressions. Note, however, that Maya's commenting conventions allows you to comment blocks of text with /*/. We've found this syntax to sometimes corrupt creation and runtime expressions, especially when saving your scenes in ASCII format, so we recommend commenting each line you want to comment with the traditional //.